Faced with the many challenges of successfully making plant grinding improvements with the use of the functional performance equation, a team was formed with 2 milling operations, grinding technical experts, and instructional design specialists. The result of these efforts is MECOM's management system to improve plant grinding performance. In this presentation, we will cover an introduction to management systems, the task analysis to determine the needed components of the system structure, and development of the training program for delivery of the system into operations. The functional performance equation provides new opportunity for making plant grinding improvements. However, a multitude of tasks are required to gain benefits from its use. Things such as accurate data gathering, including circuit sampling, monitoring and monetizing efficiency gains, knowledge of how to make cyclone adjustments, and many others. We recognized that we need to list, develop, and organize all the necessary steps in order to achieve plant grinding circuit improvements with this new tool. A textbook on management systems defines them as follows: the collection of all the required steps that ensure an organization will achieve defined objectives. Systems, or the systematic approach, are very common. Examples include the company organization chart that lays out roles of employees as they report to work each day, or your automobile, your transport system that gets you from home to the office in the morning. These systems can be complex and highly structured with many components and subcomponents. When combined, they can greatly improve the effectiveness of our work, but they can fail from just one weak component. An otherwise perfectly working automobile cannot function at all with just one wheel missing. Our objective is to improve plant grinding performance. We need to list, develop, and organize all the steps needed to improve plant grinding performance with this new tool. This collection of steps will be our Plant Grinding Process Improvement Management System. Task analysis. We need to address the question, what are all the steps needed to successfully use the functional performance equation to the maximum benefit of the operation? Task analysis is a process used to define and detail out those steps. A team made up of milling operations, grinding specialists, and instructional designers worked on this for 3 years. The outcome of all this work follows. Results of the task analysis. The final 13 components of the system. Measure circuit ore tonnage. Measure size distributions. Measure and achieve desired mill power draw. Measure ore resistance to breakage. Determine circuit overall work index efficiency. Tabulate direct grinding costs and define circuit product value. Apply functional performance. Determine ball mill circuit classification system efficiency and ball mill grinding efficiency. Optimize primary grinding within the context of the overall circuit. Achieve desired slurry pump performance. Achieve desired cyclone performance. Achieve desired ball mill conditions, such as media size and water addition. Conduct circuit sampling surveys. And finally, implement grind control. Unknown to us when initializing the task analysis, all the steps fell into one of 3 categories. First, information and measurements, both existing data on the plant equipment and the additional information and measurements required to conduct the technical analyses. Next, design, which encompasses all the steady-state relationships between circuit inputs and outputs. Subcomponents of design fall into energy efficiency, energy input, or mill power draw characteristics, and circuit product quality, in terms of recoverable metal in the downstream process. And finally, grind process control, to ensure that desired operating conditions and desired grind size are maintained with changing ore conditions. Together, these manage all the technical and economic inputs needed to maximize plant profitability with grinding circuit improvements. Finally, by definition, the MECCOM Grinding Process Improvement Management System is the structured collection of all the steps and methods needed to measure and improve plant grinding circuit performance using MECCOM and other needed metrics. What about system delivery? This is provided by means of a training program. Instructional design specialists initially supervised the task analysis. They then conducted learner and context analyses, and subsequently applied the instructional design process to develop the needed training modules and complete the program. The instructional design process is the management system that these specialists use to ensure that the training program works. That is, provides the skills to execute the grinding improvement process. Task analysis is joined by learner analysis, which outlines the attributes like language and education level of the audience, and context analysis, which describes the learning environment, primarily the location. Specific objectives, such as exactly what the learner will be able to do as an outcome of the training, are written for each of the training modules. Subject matter specialists write the first drafts, including examples and exercises. These are tested on a group of typical learners whose feedback is used for revisions. The process is repeated until each module demonstrates that a new learner can carry out the stated module objectives as shown by a certification test. A total of 21 training modules encompassing the 13 components of the grinding process improvement system were developed over the initial 3-year period. This training includes topics such as mill power and charge level measurements, work index efficiency calculations, functional performance analysis of the ball milling circuit, economic analysis of efficiency gains, hydrocyclone and pumping systems, and how to carry out plant sampling surveys. The training also includes how to properly analyze samples, conducting grindability testing, carrying out mass balance calculations on the circuit, how to evaluate the classification system efficiency, or CSE. Both the plants that participated in the initial program development and the first few new subscribers to the program used rod milling ahead of their ball milling circuits. The Ag-Sag milling module was subsequently added due to its popularity. To ensure that needed skill sets are provided to the typical players in plant process improvement work, a curriculum of training for plant personnel is recommended. However, a sole grinding champion can bring the system to success, particularly in a small operation. Likewise, implementation support can come from outside consultants or equipment vendors who have become popular subscribers to the training. Advantages of this training approach include ensuring all components of the system are provided. Skills achievement are verified through certification testing. The training system standardizes terminology, data collection and calculation forms, and reporting. The training system is fast to learn easy to use, and helps to increase operating profit. It's cost-effective, particularly due to its online delivery, and the training provides lifelong knowledge for increased job satisfaction and career growth. Some features of the training. Learner prerequisites are secondary school language and math. It is web-based, self-taught, self-paced, and interactive. The training has been reviewed and accredited for continuing education credits. 6.4 CEUs for the complete program are granted by the Engineering Institute of Canada upon completion. And it's available in English, French, and Spanish. And subscribing companies are widely located. Major subscribing companies are provided their own online training access portal, where multiple staff have completed programs at one or more properties. Here are some of the cost savings on energy and grinding media from some published success stories. For example, optimizing percent solids in the pebble mills at Tilden gave a 5% efficiency gain in those mills, 3% for the overall ag plus pebble milling circuit. At 75,000 tons per day, the electrical energy cost saving is close to $2 million per year. Improved pebble sizing likewise saved another $5 million per year in electrical energy cost. Driven by the opportunity provided by the functional performance equation for ball milling circuits, a management system was developed to help operating plants increase grinding circuit efficiency. It is both technical and economic, and it was developed for industrial plants by working with industrial plants. It provides practical tools that plant staff can immediately put to use. It is delivered online through a comprehensive training program. Application of functional performance analysis has been widely successful, and contributions to plant profits are well documented. MECOM is pleased to have been given the opportunity to help bring this technology into the industry with the help of program developers and its industrial sponsors.